and or you record, and whenever you free time, you please open the link and listen. Okay. So these are the topics. I already started rectangular distribution and normal distribution. Today I am going to explain normal distribution 2. So I am sharing the document. Please wait. This I already explained, the normal distribution 1. In this, I explained mean, movement generating function, movements, and properties. So today I'm going to explain normal distribution 2. So these are the topics I would like to explain you. So this is normal distribution 2. So this is the density function and the properties we derived yesterday. So yesterday we have proved mean, median, mode are equal. And today this is also movement generating function. Brahmakuma also explained. And this is the addition property where x follows normal distribution mu1 sigma 1 square. Y follows normal distribution mu2 sigma 2 square. Then x plus y follows mu1 plus mu2 and sigma 1 square plus sigma 2 square. This, we know that mxt is e to of mu1t plus of t1 square, t1 sigma 1 square. mx2t is mu2t plus of t2 square, sigma 2 square. While you retake, we know that expectation of x and y are two independent random variables. Expectation of x plus y is expectation of x plus expectation of xy. At the same way here, mx plus y into t equal to expectation of e power of t into x plus y, where addition theorem of expectation is expectation of tx into expectation of ty, where that is mxt into m by t. So that is, so here the same we have applied e to the power of mu1 plus mu2 into t plus of common outside sigma 1 square plus sigma 2 square into t square. This is the additive property of normal distribution, Sankalana Dharmamu. Next, the difference property is same what we have discussed in previous. So it's the same as x minus 5 follows mu1 minus mu2 comma sigma 1 square plus sigma 2 square. Here x and y are two independent random variables. Their difference is also here mentioned. X minus 5 follows mu1 minus mu2 comma sigma 1 square plus sigma 2 square. So this is I2 and difference property. And this is characteristic equation which we can use phi xt expectation of e to the power of itx, where expectation of e to the power of ix can be written as minus infinity plus infinity e to the power of tx into f of x. where f of x is nothing but x follows normal distribution. So normal density, we know that this. So you insert here, you will get e to the power of tx into density. By the transformation, you take x minus mu by sigma equal to z, where x equal to mu plus sigma z, and differentiate and apply the properties. Then you will get e to the power of mu t minus of t square sigma square. Next, cumulative generating function. So here K1 is mu, K2 is sigma square, where KR3 is 0, 4 is mu 4 is K to the power of 4 plus 3 K2 square. Beta 1 is mu 3 square by mu 2 cube. So mu 4 is 3 sigma square, 3 sigma to the power of 4. So perfectly we'll get here beta 1 equal to 0 and beta 2 equal to 3. Here see the values, mu 4 is 3 sigma to the power of 4. Mu 2 we know that variance sigma square, mu 2 square is sigma to the power of 4. By cancel, we'll get mu 2 equal to 3. So next, central and non-central moments. This is also I explained yesterday. So now we'll discuss the topics Samanya Vibhajanamu 2, part 3. This part 3, I would like to explain you that సామాన్య సంభావ్యత సమాకలని వైశాల్య ధర్మం ఏరియా ప్రాపర్టీ యొక్క ముఖ్య లక్షణాలు క్యారెక్టర్స్ అండ్ ఏరియా కర్వ్ సామాన్య యూజెస్ and normal distribution curve. All this we'll discuss in here. Here binomial, the limiting property of binomial is tends to normal distribution. That is the following conditions where n tends to infinity and p and q are very small. That is ati salpam. Where ncx p to the power of x to the power of n minus 1 can know that is the binomial distribution mass function. And here this t equal to z equal to standard normal variate, that is x minus expectation of x by standard of x. We know that normal distribution mean is np and with standard deviation is root npq. So that you substitute when x equal to 0 minus np by root npq. So while simplify, you will get root npq by tends to infinity, where x equal to n, you substitute, you will get root npq by plus infinity. So x యొక్క విభాజనము మైనస్ ఇన్ఫినిటీ ప్లస్ ఇన్ఫినిటీ మీద అవి ఇచ్చిన విభాజనము కంటిన్యూస్. సో పై రెండు నియమాల దృష్ట్యా 1 యొక్క అవధి రూపము పెద్దదైన r కు స్టైలింగ్ ఉజ్జాయింపు we have one formula styling approximation, that is limit x tends to infinity x or factorial equal to root 2 pi e to the power of minus r to the power of r plus of. So that r to the power of x plus of. So that you substitute here r to the power of r plus of. Limit x tends to infinity x factorial e to the power of minus of r to the power of x plus of. So that you substitute limit n minus x tends to infinity, where in x place we can take n minus x factorial e to the power of minus r e to the power of minus r, that is root 2 pi into e to the power of minus r means n minus x e to the power of n minus x plus of. So as n tends to infinity, x tends to infinity. So limit x tends to infinity, where probability x equal to x, that is limit x tends to infinity n factorial x factorial n minus x factorial p to the power of x q to the power of n minus x. Substitute all these, you'll get root 2 pi e to the power of minus n to the power of n plus of root 2 pi e to the power of minus n minus x to the power of n minus x plus of. So this. So you will get, well, this confirmation x equal to np plus z into root npq. You come divided by np, you will get this. So this is here differentiate dz equal to 1 by root 2 npq dx. So z యొక్క సంభావ్యత అవకలన అవధిలో 3 తో ఇవ్వబడుతుంది. So here dgx z is small gz, limit n tends to infinity 1 by root 2 pi into 1 by capital N dz. So where Kaplan equal to x by np whole graph x plus of n minus x by nq whole graph n minus x plus of. So equation, both side you take log, where log n equal to log x plus of x by np plus n minus x plus of n minus x by nq. So while simplify, you will get this. So these are the simple equations. Careful to see ma. So this is first line, and this is second line, and this is third line, this is fourth line, and please see that. Please see how we have done the simplification. Please see that. Each and every step carefully, please see. I am sharing here. Just only log m plus log n. Log mn is log m plus log n. So that formula we applied. Constant common terms come outside. Please see this. So now you will get 1 by root 2 pi e graph minus z squared by 2. This is standard normal variate function. Okay. So here, ఇది మధ్యమము 0 విస్తృతి. Here mean is 0, variance is 1. So z equal to x minus mu by sigma is the standard normal variate, and Jacobian using transformation 1 by sigma. Here, substitute in 6 equation, you will get expectation of x is mu, variance of x is sigma square. And this is the density 1 by root 2 by sigma e of minus x minus mu by sigma whole square. So next, normal distribution as lambda tends to infinity. Also, we can find the value. So now, standard normal distribution, x అనే యాదృక చలరాశి మధ్యమము means median is mu, విచలనము sigma. Say z equal to x minus mu by sigma. The expectation of z is, you will get 0. Variance of z is 1. This we have proved. Where z follows x minus mu by sigma, expectation of z is 0. Variance of z is 1. This is a very, very important. One cannot know. This is the step is very important here. Variance of x minus mu by sigma. Variance of constant is what? Variance of ax is a square variance of x. Here, sigma comes side, that is sigma square, variance of x minus mu. So, variance of x minus y, we can write like this. So, variance of mu is, here, variance of constant is 0. So, mu is a constant, it is 0. So, variance of x is sigma square. So, by 1. So, like this. So, next. Okay. So, next. Samanya Chalarashi Madhyamamu mean 0. Standard deviation is 1. Z Brahmanic Vivarjan to Sambhavya Santa Pramayamu. Then pi of Z, its density is 1 by root 2 pi. Sigma is 1 here. Okay, sigma is 1 here. Mean is 0. So then what is the density? 1 by root 2 pi e to the power of minus z square by 2. That is the density of standard normal variate. Okay, this is very, very important. Standard normal variate. So here mean is 0. Variance is 1. So now, this is area property, where x follows normal mu and sigma square. Then probability is lies mu less than x1, that is mu to x1 pi of x dx. Where this is mu to x1 1 by root 2 pi sigma e to the power minus of x minus mu by sigma whole square dx. Where x minus mu equal to sigma, then x minus mu equal to sigma z. While substitute x equal to mu, z equal to 0, where x equal to x1, then this is z1. So that is 0 to z1. So that is x is here 0 less than mu minus mu, x minus mu by sigma. So that is z less than z1. So that is 0 to z1, 1 by 2 pi e of minus of z square by 2. So which is phi of 0 to z1, e power minus z square by 2 is root 2 pi, and that gets cancelled, phi of z dz. Where phi of z equal to 1 by root 2 pi e power minus z square by 2. So this is probability, some normal probability density function, where z equal to 0, z equal to z1 అనే ద్వితీయ నిరూపకాల ప్రామాణిక సామ్యం పరిబద్ధపరిచే వైశాల్యం z1 ఎక్కువ విభిన్న విలువ 0.0 అంతంలో పట్టింది. సో హియర్ x equal to mu minus sigma, mu plus 2 sigma minus 2 sigma, mu minus 3 sigma. Here mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. Where x equal to mu, you substitute, you will get z equal to 0, z equal to minus 1, z equal to minus 2, minus 3. And here 1, 2, 3. So here mu minus sigma, mu plus sigma, and the probability, that is probability mu minus less than sigma less than x less than mu plus sigma, that is mu minus sigma to mu plus sigma f of x dx. That is equal to x minus mu by sigma, that is mu minus sigma by mu minus sigma, that is minus 1 less than z less than 1. So minus 1 to 1, phi of z dz. That is, to this we can write as minus 1 to 0, 0 to 1. So that we can simplify 0 to 1. And minus we can change 0 to 1. So 2 into 0 to 1, phi of z dz. So this is a 0 to 1 from standard normal tables. We'll get the value 0.3413. And this is the 0.6826. So where the value lies 0 to 1. So next, minus 2 less than x less than u plus 2. Minus 2 to 2, 2 into 0, 2. So here phi of z is 47. 0 to area is 0.47. And this is 0.95. And next, minus 3, mu minus 3 less than mu plus 3. Minus 3 to 2 plus 3. So that is 2 into 0 to 3. So this is, we can write as mu plus or minus 3 sigma, that is modulus of z greater than 3. So 1 minus, we write 0.9973. So this is the value 0.0021. So 0 to 1 is 68, 0 to 2 is 95, 99, 95, and 0 to 3 is 99. So these are 99%, 95%, and 1%, 10%. So these are the values. Very, very important one. That is, no plus or minus sigma lo untundani, we can prove that. So 99% we will declare the value is right by using the normal distribution. Okay. So సామాన్య చలరాశి mu ప్లస్ ఆర్ మైనస్ 3 సిగ్మా వ్యాప్తిలో ఉంటుందని అంచనా వేయవచ్చు. సైద్ధాంతికంగా సంభావిత వ్యాప్తి మైనస్ ఇన్ఫినిటీ నుండి ప్లస్ ఇన్ఫినిటీ అయినప్పటికీ. So in the normal distribution, the variate spreads to mu minus 3 sigma to mu plus 3 sigma. And its percentile value is 0.9973. So 99 percentile value, the variate is that to from -3 to +3. That you able to understand. So here, Samanya సంభావ్యత వక్రము కింద పరిబద్ధమయ్యే మొత్తం వైశాల్యం 1. We know that total probability is 1. సో సామాన్య ప్రభావిత పట్టికలో మనకు ప్రామాణిక సామాన్య వక్రము పరిమితపరిచే వైశాల్యాలు ఇవ్వబడటం వలన సంఖ్యాత్మక సమస్యల్లో మనం చలరాశి తీసుకుంటే బదులు చలరాశి z ను ఉపయోగించవచ్చు. సామాన్య వక్రం కింద పరిబద్ధమయ్యే వైశాల్యం కనుగొనటకు ఏదో విధంగా probability of 0 capital less than z రూపంలో అనువర్తించగా పట్టికలో మిమ్మల్ని ఉపయోగించుకోవాలి. We have normal tables. We can find out for whatever the value, we can find the value. We can able to find the value. So here, characteristics of standard normal distribution. Okay, and here the density function, and here x equal to mu, and x equal to -infinity, and where we can find this value is 1/2 pi sigma. So now see this curve once you see, please. Now whatever we learned that if you have wrote the points, please see. First point is we proved that beta 1 is 0, beta 2 is 3. Okay. And the second point, మధ్యము దృష్ట్యా బేసి తరగతి భ్రమకాలన్నీ శూన్యాలు. All odd order moments are 0. Even order moments are exist. 135 to m plus 1 sigma to the power of n. f of x సంభావ్యత అగుట వలన రుణాత్మకం కాజాలదు. కావున వక్రం యొక్క ఈ భాగం ఏ భాగం కూడా x అక్షం కింది భాగంలో ఉండదు. స్వతంత్ర సామాన్య చలరాశి రేఖీయ సమయం కూడా సామాన్య చలరాశి. లీనియర్ ట్రాన్స్ఫర్మేషన్ ఆఫ్ 2 ఇండిపెండెంట్ రాండమ్ వేరియబుల్స్ ఆల్సో లీనియర్ నార్మల్ వేరియేట్. వక్రానికి x అక్షం అనంత స్పర్శ రేఖ అసింపటోటిక్ అవుతుంది, మీన్స్ సమానం అవుతుంది. వర్గం యొక్క సతి పరివర్తిత బిందువులు పాయింట్స్ ఆఫ్ ఇన్ఫ్లెక్షన్ వేర్ x equal to mu plus or minus sigma. As I explained you, where x equal to mu minus sigma, mu plus sigma, mu minus 2 sigma, mu plus 3 sigma, 2 sigma, mu minus 3 sigma, mu plus 3 sigma. That the percentile value I explained that. Then quarter deviation, mean deviation, standard deviation. That is 10 is to 12 is to 15. So where MD is median, HD is standard deviation, QD is quarter deviation. సామాన్య విభజనంలో మధ్యమం నుండి మధ్య విచలనం దాని క్రమ విచలనానికి 4/5 సిగ్మా. గరిష్ట ద్వితీయ నిరూపక మధ్యమ x mu వద్ద ఉంటుంది. సామాన్య విభజన వక్రం ఒకే ఒక శిఖరాన్ని కలిగి ఉంటుంది, కావున ఇది ఏక బహుళకం, ఓన్లీ వన్ మోడ్. వక్రం యొక్క 1 tail 2 tails is spread infinite, so that is సృష్టించవు. మ్యూ అండ్ సిగ్మా తెలిసినప్పుడు గణిత సమీకరణం పూర్తిగా నిర్వర్తించబడుతుంది. మీన్, మీడియన్, మోడ్. సో పూర్తి వైశాల్యాన్ని 2 విభాగాలుగా విభజిస్తుంది. వేరే x equal to mu, that is z equal to 0. ఎడమ భాగాల వైశాల్యం 0.5 ఉంటుంది. దిస్ ఈస్ 0.5 and 0.5. 68% is mu minus sigma, mu plus sigma. 95% is mu minus 2 sigma, mu plus 3 sigma. 99% is mu minus 3 sigma, mu plus 3 sigma. So this is the area, the total area. This is 0.5 and this is 0.5. Where the variate lie mu minus sigma, mu plus sigma is 68.2. Mu minus 2 sigma, mu plus 2 sigma is 95. Mu minus 3 sigma, mu plus 3 sigma is 99. So that is normal distribution. So now uses. So please, already I explained all the topics. So please see, these are the uses of normal distribution. Please see 1 to 6 points. I'm sharing you. Please see this. Please read all this. Very, very important. Normal distribution is very, very important in the BSc level, in the statistics level. So now these are the 6 uses. Now సామాన్య విభాజనము లేదా సామాన్య వక్రం యొక్క సంధానం. So this is ప్రతిరూప దత్తాంశానికి దీర్ఘచతురస్ర వక్రానికి బదులుగా సామాన్య విభాజనంతో మృదు వక్రాన్ని సంధానించి జనాభా యొక్క లక్షణాలను అంచనా వేయవచ్చును. సామాన్య విభజనాన్ని కనుగొనుటకు 2 పద్ధతులు కలవు. ద్వితీయ నిరూపక పద్ధతి సంభావ్య వక్రం యొక్క ద్వితీయ నిరూపకమ పట్టికను అనుసరించి సామాన్య వక్రాన్ని సంధానించవచ్చు. వైశాల్య పద్ధతి సామాన్య వక్రము పరిబద్ధపరిచే మొత్తము వైశాల్యము అగుట వలన వైశాల్యాల పట్టికలను గురించి సామాన్య వక్రాన్ని సంధానించవచ్చు. సో దీస్ we are learned these outcomes. అని సామాన్య విభజనాన్ని ద్వితీయ విభజనంలో అవధి రూపంలో చూపుము. These are the questions. Please see. These are the topics. These are the questions may ask in examinations. Please, I am sharing. Please go through all these topics. Next, this is the part 2, other continuous distributions. Those are gamma distribution, beta distribution, and Cauchy distribution. Here also X is continuous random variable which lie in certain limits and which can be used in life testing experiments, and also we can use reliability theory. And here gamma. So these are in part 1, part 2, those we can apply um, in కన్నంలో జీవిత పరీక్షా ప్రయోగం means life testing experiments. విశ్వనీయత సిద్ధాంతం reliability theory means rectangular distribution, normal distributions can be applicable in life testing experiments and reliability theory. So here some more continuous distributions. Those are gamma distribution, beta distribution, Cauchy distribution. So in this part 4, we'll discuss briefly about these properties, uses, and all we can learn now. So let me share the topic. Please wait. Please note this. So now one of the distribution is gamma distribution. In this lesson, we able to learn these objectives, introduction, gamma density, gamma variate, gamma characteristics, so relations. So these questions on this topic. Okay. Now introduction, where the gamma will apply. So in this gamma విభజనం మరియు దాని ప్రత్యేక సందర్భమైన ఘాతీయ విభాజనంలో జీవ పరీక్ష ప్రయోగములందు మీన్స్ బయాలజికల్ ఎక్స్పెరిమెంట్స్ మరియు రియలబిలిటీ లో ఆల్సో we can apply. At the same way, normal distribution, అగ్రికల్చర్ సంబంధ ప్రయోగములలో ప్రయోగ దోషములు అనుసరించే విభాజనంగా ముఖ్య ప్రాముఖ్యతను పొందిన విధంగా ఘాతీయ విభాజనం పైన పేర్కొన్న రంగములతో ప్రాముఖ్యమును పొందినది. సో విఫలత రేటు స్థిరంగా ఉన్న సందర్భంలో దీన్ని వాడతారు. మీన్ ఫెయిల్యూర్ ఈస్ కాన్స్టెంట్ ఇన్ దిస్ డిస్ట్రిబ్యూషన్. సో దాట్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్. So here this is a point. Next, in gamma distribution, we always positive. So let me share the topics. So this is 0 to infinity, x power of p minus 1, e to power of minus x dx. No, gamma density we can call. This we can denote like this. We can write like this. Gamma p. We can change any parameter. Okay. Now, so gamma p is 0 to infinity x power of alpha minus 1 e to power of minus x, or x power of p minus 1 e to power of minus x. If you take gamma alpha, if you write alpha, if you take p, you write p. So p is not here probability. This is a constant. Okay. Here integrate, you'll get e to power of minus x, e to power of p minus 1, and substitute the limits, you will get p minus 1 gamma p minus 1. So if alpha, we can write gamma alpha is alpha minus 1, gamma alpha minus 1. Okay. So that is. Next, gamma n. We can write this is the formula n minus 1, n minus 2, etc. Gamma 1. h0 to infinity e of minus x dx. Gamma 1 is 1. Gamma n is n minus 1 factorial. Gamma 1 2 is root 2 pi. Here 3 we learned. One is gamma alpha is alpha minus 1, gamma alpha minus 1. And gamma 1 is 1. And gamma 1 by 2 is root pi. These are the three very, very important. Please denote. Please note down. These are star mark. These are star mark. Next. And this is the gamma density. What is the gamma density? I'll write. Now I want to draw this. Okay. Now this is the gamma density. F of x equal to lambda to the power of p by gamma p x to the power of p minus 1 e to the power of minus lambda x. Lambda is also constant. X greater than or equal to 0, lambda less than 0, p greater than 0. Here lambda y less than 0, p is greater than 0. Okay. So 0 e to the power of minus ax, where a is less than 0, a to the power of alpha. Okay, p is greater than 0. So x అన్నది స్కేల్ పరామితి, లాంబ్డా అనేది ఆకృతి. x అన్నది స్కేల్ పరామితి, లాంబ్డా ఆకృతి పరామితి p కాగల గామా చలరాశి దాని సంభావ్యత విభాజనము గామా విభాజనం అని అంటారు. x అన్నది స్కేల్ పరామితి లాంబ్డా, ఆకృతి పరామితి p కాగల గామా చలరాశి అనే దాని సంభావ్యత ప్రమేయము అని అంటారు. Where x follows g, lambda, comma p. These are two parameters where lambda is shape parameter and p is lambda is constant and p is here shape parameter. Scalar. Lambda is scalar and p is shape parameter, where lambda is less than 0 and p is the shape which is greater than 0. So now, what is the mean of gamma distribution? We know that mean can be found out by using expectation of x. Expectation of x is nothing but x into p of x. Here p of x is nothing but gamma density. Here gamma 2 parameter density. So apply in this gamma 2 parameter density, apply the differentiation and all those properties, we will get the value is p by lambda, p by lambda or alpha by a, whatever. Next, expectation of x square mu2 dash, that is expectation x square into f of x dx. So x square into f of x. Now p into p plus 1 by lambda square, and variance of x is p by lambda square. Here, if you substitute lambda equal to 1, then what you will get? 1 by lambda. So mean and variance ఏకపరమతిగాను అంకమధ్యము విస్తృతి అవుతుంది. అంకమధ్యము is 1 by lambda, విస్తృతి standard deviation is 1 by lambda. If lambda less than 1, అంకమధ్యము విస్తృతి కన్నా తక్కువగా ఉంటుంది. లాంబ్డా గ్రేటర్ దెన్ 1, అంకమధ్యము విస్తృతి కన్నా ఎక్కువగా ఉంటుంది. So here విస్తృతి means variance. So variance of x is 1 by square. Mean is 1 by lambda. Mean is 1 by lambda. If lambda equal to 1, p. If lambda equal to 1, p. So if you substitute in gamma distribution, lambda value is 1. Its mean and variance are equal. If lambda is less than 1, mean is less than Standard deviation, variance. If lambda is greater than 1, mean is greater than variance. అసౌష్టవత మరియు కకుతత్వ గుణకములు. It's not a normal. It's not a normal. It is a skewed. This is a skewed curve. అసౌష్టవత. So normal distribution is skewness is 0. But in gamma distribution, it has some value of q. This is Asaustava distribution. No? So that we can explain in following. Now, skewness. So here, you know that skewness is mu t squared by mu 2q. So here, x follows gamma distribution. Its mean is p by lambda. And mu 2 dash and or equal to 3 or equal to 4 will get these values. It has central moments in terms of normal central moments. We substitute mu 3 square by mu 2q, where we will get 4 by p. Beta 1 is 4 by p, where p is what ma? P greater than 0. P greater than 0. Lambda is p is the shape parameter. Lambda is scalar. So here p greater than 0 కనుక గామా విభజనం ఎల్లప్పుడూ అసౌష్ఠవతను కలిగి 4వ కేంద్రీయ ఘాతిక mu4. That value is beta 2 is 6 by p. 4 by p and 6 by p. Beta 1 is 4 by p. Beta 2 is 6 by p, which is skewed distribution, which is there in normal distribution, skewness is 0. But in gamma distribution, there is some value of skew. Okay. Next, x follows g lambda, that moment generating function, ఘాతికోత్పాదన ప్రమేయము. One can know that MHD is nothing but expectation of e to the power of x. We can write minus infinity plus infinity e to the power of dx f of x dx, where one can know gamma distribution density is this, where expectation of e to the power of dx. To simplify, you will get 1 minus t by lambda whole to the power of minus p. 1 minus t by lambda whole to the power of minus p. Okay? Which is chi-square. Chi-square is 1 minus 2n whole to the power of minus n. Here, 1 minus t by sigma, t by lambda whole to the power of minus p. Okay. Characteristic function 1 minus it by lambda whole to the power of minus p. Next, L2 property. If x follows gamma lambda 1 p1, lambda to P2, both are independent, then phi of x plus y into t is also phi x into t, phi y into t. That is 1 minus it by lambda whole to the power of minus P1 plus P2. Next, Bahulakamo mode. The frequency is maximum where f of x is attained the maximum value, that is the mode. Here, f double x, f dash x is greater than 1, f x equal to p minus 1 by lambda, p greater than 1 but the mode, p minus 1 by lambda. And the relation between gamma and chi square, if you substitute lambda equal to 1 by 2, p equal to n by 2, it follows chi square distribution. Okay. And this is exponential. When p equal to 1, lambda into e to the power of minus lambda x. So in gamma distribution, if you substitute p equal to 1, it follows exponential distribution. Gamma విభాజనంలో ఆకృత పరమాతి p equal to 1 అయినా అది ఘాతీయ విభాజనం అనుసరిస్తుంది. That is exponential distribution. If lambda equal to 1 by 2, p equal to n by 2, it follows chi-square distribution. So here the property Z1, Z2, etc. Zn do independent standard normal variates. Then x square equal to Z1 square plus Z2 square, etc. Zn square. Another n independent chi-square random variate అవుతుంది. So these are the very, very important points. Please make note. This is skewness is not 0. It has the skew distribution. 4 by p is skewness. 6 by p is kurtosis. And which is p greater than 1. It is p minus 1 by lambda is mode. Okay, mean is p by lambda. Variance is p by lambda square. And p equal to 1. P equal to 1. Mean and when the mean and variance are equal, is here Vishruti is what? Mean is p by lambda. Variance is p by lambda square. And p equal to 1, 1 by lambda. Vishruti is 1 by lambda square. Standard deviation is if lambda equal to 1, p by lambda, p equal to p. So that is lambda is scalar. If scalar parameter is 1, which gamma distribution mean and variance are equal. Where lambda equal to 1, where lambda is less than 0. We know that. So if us assumes equal to 1 value, why? Because mean is p by lambda. Variance is p by lambda square. If lambda equal to 1, 1 square is also 1. Then mean p. So it is observed that in gamma distribution, in gamma variate mean equal to variance, where the value is p. Okay, the very, very important. It is also follows additive property and it is also having mode, mean, variance, mode, which is a skewed distribution. Its beta 1 is 4 by p. Its beta 2 is 6 by p. Okay. Its moment generating function is 1 minus t by lambda whole to the power of minus r whole power of minus p. And its characteristic function 1 minus IT by lambda whole to the power of minus P. Okay. Now, some transformations. What are the transformations? In gamma distribution, if you substitute lambda equal to 1, which follows for P equal to 1, which follows exponential distribution. If gamma lambda equal to 1 by 2, P equal to n by 2, which follows chi-square distribution. So we know that chi-square moment generating function is what? 1 minus 2n whole power of minus n by 2. So that is. So these are the topic. Please do exercise. So shall I stop? Tomorrow we'll go the P-talk. So I am sharing from the beginning. Please go through all topics. Okay. So please see all the topics. I'll close. Today's the topics. Okay, thank you, BRAOU team.